Hello, everyone. Let me share my screen. This is it. All right. Hello and welcome. And thanks for DevOps Pro Europe for having me over. So, today we'll be talking about CI CD speed. You can't hear my voice. Does my voice, can you hear me now? Ah, right. Someone muted. Anyway. Hello, everyone. Today we'll be talking about speed of CI/CD systems, builds, and runs. So before we begin, have a think for yourself and do let me know in the comments on that side, I believe. What speed do you expect from your CI/CD? Like a single run? What's the ideal scenario? How quickly does it run? Or on the other hand, what's the less ideal scenario? What's a terrible scenario? What's way too long for you? And in your history, in your past, what was the worst CI/CD build time that you kind of had to deal with? I'm sure many of you have agonizing stories of being stuck with very long running and hard to debug builds. Someone said 5 minutes. Yeah, 5 minutes is pretty good. I think pretty pretty spot on, but obviously it depends on every team. Anyway, my story went something like this. Yes, I am talking about an all-day build. How does this look like? Wake up one morning, and obviously the first thing you do is check Twitter, and the second thing you do is check email. And at the top of your list of emails is your CI telling you, hey, your build has failed from yesterday. And as we're good developers, we open up the laptop as we're making coffee and see what went wrong and try to debug it, make some changes, push, commit, push, and kick off another CI build. That's great. And then we're off to work, right? Um, at work, we're obviously working for the whole day and making all the usual things, right? New features, new bug fixes, code reviews, everything that you do. Anyway, this is a real story. It's about 6 years old, from 2015-ish. I was working on a mobile team, and honestly, we were following every great engineering practice that we knew of that existed at the time. So essentially, everything was built according to the solid principles, designed with clear architecture in mind. So really nice kind of splitting of responsibilities, all that stuff. And everything was written test first. And by test first, I don't only mean unit test first, but also functional test first. We had to write every single test before we actually start writing any application code, any features. What does it look like? So if you're thinking about how features are kind of created, you speak to a product manager who kind of tells you, okay, we want to do these things. And then you kind of query that product manager and have a conversation with them. Okay, but what are you actually expecting? And before we could start working, we essentially wrote a series of functional tests for every single feature, what the acceptance criteria was. It was written in code, it was decided upon, and it was signed off by that product manager. So 100% test coverage is a reality, and we had it. In any case, I'm at work, I'm about to close off for the day when I get another email. And yes, it's my friend CI again, and it's telling me that the build has failed. And yes, it's the same build that I kicked off early in the morning. but that's still fine, right? It's 2 in a row. I mean, I've seen worse, right? It happens. I must have missed something, so I open up the laptop again and make some changes, commit, push, which will kick off another CI build, and off I go home. And tomorrow morning, it's all going away, right? Well, no. The next day, the story repeats, and so does the next day. And I think it went on for a few weeks. And now you might start to get the idea of what's where a problem might lie. Essentially, we had accumulated by kind of working on our new features, our new bug fixes. We were accumulated this kind of super long queue of things we wanted to ship but couldn't ship because the CI was really not letting us. And this was pretty agonizing because you kind of you really want to ship. Like your product manager is expecting you to ship, your stakeholders are expecting uh, your product manager to ship something, and so on. And also your users are expecting the bugs that they reported to be fixed as well, which is not a good look on any development team if you can't ship. And yes, yet you are looking at this red light as a team that doesn't turn green, and everything is stuck, everything is terrible. And so what do we start thinking about is, do we really need that CI? Do we really can't we just like, make the build manually and job done, right? Well, I mean, not so fast. The thing is, if you turn off the CI and do the build manually, even if you test it manually, you're still creating a lot of work and a lot of risk for yourself. I like the analogy of the ships that were waiting in the Suez Canal by the for the Ever Given. So that's this famous ship that was stuck in the Suez Canal, blocking all shipping between Asia and Europe for I think more than a few days, maybe a few weeks. Basically, some ships were deciding, okay, we don't want to wait for these people because they are obviously don't know what they're doing. They're just stuck here, and they went across around Africa to get to Europe from Asia. And if you're thinking about the journey that they had to do, instead of doing a couple hundred kilometers, they had to do a few thousand kilometers. And that's the analogy of turning off your CI/CD and building something manually and testing something manually, just because that's how much the automation is doing for you. So yeah, I don't think that's a viable option. I never have thought this was a viable option, because also the red build is is a signal. It's telling you something, and it's telling you the state of your application is frankly unshippable. You can't ship because it doesn't build. And that's honestly, that's CI doing what it's supposed to be doing. Anyway, today we'll look at how to avoid that, how to make builds faster and avoid these type of scenarios. My name is Zan Markan. I'm a developer advocate at Circle CI. I've broken many more builds than I wish to, I want to admit, but here we are. If you want to get in touch, I'm pretty active on Twitter, at Markan, or you can also email me with any questions offline at zan@circleci.com. Anyway, so this talk is all about making sure your builds go faster and you really optimize your CI/CD pipelines so that, yes, your tests don't take all day. And I see that someone in the comments said the worst build they ran was 15 hours. Yes, that is I can relate. I have to say. Anyway, This is a pretty agnostic talk. It's going to work for any, the tips I'm going to be covering are going to work for any CI/CD setup, any system. But I do work for Circle CI, so I'm going to be using examples from Circle CI. If you don't know us, we're the leading CI/CD platform, shared CI/CD platform out there, and I just want to cover a little bit of basics of how it all works, so you have an idea when I kind of mentioned the examples later on in the talk. There are two parts to Circle CI. One is the actual pipeline configuration, which is a YAML file, which is in this Circle CI slash config.yaml file, which is in the top of your repository. So it sits alongside your regular project, and that's basically where you tell it what you want it to do. And in that config file, you put in jobs, workflows, commands, and some other things. So jobs are like the single kind of unit of like execution, if you will, where you define the environment you want this to run. For example, a particular Docker container based on an image, or a virtual machine, or running on Linux, Windows, Mac OS, whatever you want to run, and a set of steps. For example, I have this build step and a build job, and then test job, which then kind of contain a bunch of uh, like run commands. That's what we call them. And they can be CI instructions like checkout, which kind of gets the code off, or run commands, which are essentially any command line instruction that you want to pass. Or they can actually refer to other commands defined either elsewhere in this file. So if you kind of have more complex builds, you can actually kind of abstract commands and reuse them elsewhere, or actually pull them in from reusable sets of configuration, which are called orbs. So orbs are like for various programming languages, Node.js, Python, Java. They all have their own orbs, which kind of come with their own jobs, steps, and commands, and all that stuff. And the way everything is orchestrated, we put them into workflows. So workflow, if you can think about it, is a collection of jobs that execute in a given order. You can add filters for like branches, for tags, or even cron jobs for like if you want to make some sure that something runs periodically as opposed to on every single commit. By default, this will execute on every single commit, but obviously you can set this up as you might want. Anyway, that's the Circle CI configuration side of things. The other part is the dashboard. Dashboard basically gives you a view of everything that's happening, all the projects that are kind of configured with Circle CI that are running in there within your organization, maybe GitHub organization, for example. And that kind of gives the whole team a visibility of what's going on. And you can then drill into individual jobs, workflows, and so on. So that's kind of how this all works. So you have a little bit of context for later on. Anyway, let's move on. So slow builds. When do you know you have a problem? I mentioned an extreme example already, which was when you're actually thinking that you'll be better off when you turn off the CI and build things manually again, locally on your machine, and test them locally as well. So that's like a very, very acute sign of a terrible problem with your CI that's probably due to some kind of slowness, or kind of impossibility to debug because of slowness, usually. On the other side of the spectrum, you can just be noticing increasing build times. For example, maybe the builds used to be 5 minutes and now they're 10 minutes, and or they used to be 10 minutes and now they're 30 minutes, and they're kind of slowly, really slowly getting on your nerves. And but the problem with increasing build times is it's hard to detect them like straight away. it's not that your builds are going to go from 5 to 10 minutes within a day, because code is grown. You add features, you're just kind of gradually adding complexity, you're adding more tests, which kind of only slowly kind of creep up the build times. And honestly, that's normal. You're expanding your app, the build times will expand as well, but they don't do it from today to tomorrow, essentially. Or maybe you have a problem getting the builds to green when they're broken, so they're staying red for a longer and longer time. Again, that's something that doesn't really kick off very quickly. So unless you're kind of capturing this on a larger time frame, you're not going to see this becoming a problem. But my favorite thing that tells you that you have a problem with your CI is your team. Basically, your team tells you that they have either low confidence in builds, or even better, they're complaining about CI. And if one person complains about CI once at a retrospective, maybe they've been debugging it. But if this is a recurring story that the whole team kind of keeps reiterating across multiple retrospectives, multiple weeks, months, days, whatever, that's when you know you also have a problem, without actually getting to the point that you want to turn it off and do things manually again. So, okay, we've identified we have a problem. Now, how do we fix it? The best thing to do is actually pinpoint the root cause that's causing the actual problem, causing the slowness. And we do that by measuring things. One is obviously measuring how long the whole thing runs, which is very, very rudimentary. It's just like making a timestamp when you begin and making a timestamp when you end. And you can do that with any type of technology, or any like track it in any way, essentially. Even like a Google spreadsheet will do. Obviously we have better tools for that, but it's a rudimentary tracking measure. The same with time to green, or individual kind of job runs, that kind of stuff. um, Again, depending on what tools you're using, you can actually go a lot more deeper, a lot more you can look at it a lot more precisely, looking at individual job, how long it takes. For example, my build job takes 1 minute, my unit test jobs takes 1 minute, and my functional test jobs, in our example that I called out in the beginning, they took the bulk of the time. So this is something you can actually see and measure. The other thing is, on a job level, you can see, okay, maybe my one of the jobs is especially flaky compared to others, is failing more often than the others, or takes longer to fix it than the others. Or maybe you can even go deeper and look at individual test level, test suite, that's kind of to pinpoint one that's kind of causing a lot of problems. So depending on your tools, you might have the ability to kind of really identify the problem very easily, just kind of looking at what you have available. With Circle CI, obviously, we have this Insights tab. And yes, this tells you essentially like a graph of how long have your build times have been going, like through time over the last 90 days. You'll see, okay, it's kind of grown. That's for a whole workflow pipeline level. But you can also drill into jobs, for example, see the success rates for jobs, or durations, and I mentioned tests as well. So that's something you can actually get some good insights from. Anyway, now that we have identified what the problem might be, or where the problem might be, let's go and fix it, right? The best way to do it is by, identifying, we've identified the problem, and we can then see whether some of the approaches that I'll be mentioning work for your use case. First one, the most rudimentary one, is getting a bigger machine. By that, I mean a bigger virtual machine or a bigger machine that runs a Docker container. So if you're thinking about it, common identifiers are essentially like out of memory errors. If you're running into out of memory errors on every 2-3 builds, you could be better off by increasing this amount of memory that you're allocating to the thing that's building it. Again, there is like some processes that some build tools that can utilize multi-threading, compilation that utilize multi-threading, and is CPU heavy. So yeah, increase the number of cores, increase the size of the CPU that you're giving it, and it will go faster. My favorite, easiest way to detect whether you'll kind of benefit from a bigger kind of faster machinery is whether you notice that you're running something on a local machine and it goes way faster than it does on a CI. And then you're looking at why this might be, and you're looking at your laptop, maybe like a 1-year-old, 2-year-old MacBook Pro i7, 16 gigs of RAM, compared to the CI that has, yeah, 2 CPU cores and 4 gigs of RAM. And then you're asking yourself, why is it taking 3 times longer? Yeah, increase that size, get the CI's execution environment to be on par with your like a local development machine. You'll be fine. Anyway, if you're using a cloud-based tool, that's very easy toggle. You just kind of specify the resource class. In our case, you can do X large, large, medium, XXX large, and that's basically it. Um, and that's like in the same configuration file. Obviously, depending on the tool that you're using, this might be a bit different. And obviously, if you're not using a cloud-based tool, it might involve ordering something, some more RAM, and physically installing it into your box. But the idea is the same. More resources, speed goes up, and time goes down. Okay, so we've kind of used the right size of resources. Our machinery is adequate to the job. So what else can we do? One thing we can do is make sure that we're running things in parallel. What I mean by that is essentially speed up by running things in multiple streams at the same time. And you can do that on the job level. So you can run multiple jobs, for example, all the different types of testing, for example, unit tests, integration tests, functional tests, security scans. You can actually run those in parallel at the same time. So they kick off at the same time, but they finish at the when the last one finishes, which ultimately, compared to running them one after the other in sequence, is a lot faster. Um, the way this is kind of configured in different CIs is obviously depends. With Circle CI, they run by default in parallel, so you don't really need to do anything. Only if you need them to kind of run one after the other, you need to kind of specify, okay, this one requires the other one to run. But the second one is even more interesting. If you have very large test suite like we had with our functional tests, you can think about splitting them within that suite. So essentially, you're running multiple jobs that run only a subset of the tests in that test suite. Again, with Circle CI, that's pretty straightforward. Every kind of environment that we offer comes with the CLI installed, which lets you kind of specify a subset of the tests that you want to run. And you can actually split them by time, file name, or file size. My favorite one is actually by splitting them by time, because it kind of uses historical runtimes to figure out a combination of tests from various files with various names that will run about the same for the same time. So you have, for example, six parallel jobs. They'll all run for about the same time, obviously, give or take, because it's still kind of not 100% accurate, but you're getting roughly 6 equally running jobs. And yeah, the next thing is to just specify the parallelism and you're done. You can also do manual things like set of environment variables and that kind of stuff. But yeah, that's going parallel, which ultimately really does speed things up. Next one is caching. Cache is something you can benefit from on every single subsequent run. By caching is nothing other than deduplicating parts of your work. I like to split it in two parts. One is what you need, and the other one is what you build. What you need is essentially the dependencies that you need in order to kick off the build for the build to start. So I'm talking project dependencies, compilation dependencies, whatever you need installed on the machine in order to make the job run, all the way to the actual git cache. Git cache obviously is very easy because most CIs actually utilize that already. Dependencies, sometimes you need to do a bit more work because if you're just thinking about it, if you run npm install every single time, it will download everything from npm. But you can actually cache things on the package file or package log file. If that changes, we'll re-download. If it doesn't change, we can actually store those dependencies in that cache. There's like a bunch of utilities for making this a lot faster, a lot easier. But ultimately, my favorite thing is with CircleCI, at least, to use the node or whatever the respective orb is for that language, for Node.js, for Python, for whatever, which usually comes with some kind of install dependencies command, which does that out of the box. So it does all the caching for you, which is super easy. So you run it once, caches it, and then every subsequent run, which doesn't change dependencies, will just kind of make it that much faster. And if you're thinking about like create React app, that creates a lot of dependencies, and yeah, you can save minutes each time you run something with just not installing everything every single time. Last one is if you're relying on Docker to make your builds, you can pick the right Docker image that has everything pre-installed. So if you need to install something on an environment like with apt-get or whatever you're using, maybe you can skip that and you can build your own Docker image that has all the dependencies already built in that you need to build something. So yeah, that's kind of before you even start building. Once you start building, if you're thinking that maybe you have a lot of jobs that are running different tests or a lot of different scans, you could potentially build something once, like build all the artifacts once, and then run tests against those artifacts in subsequent runs, as opposed to caching them building them each single time when you're running, for example, functional tests or unit tests or integration tests. So that's something you can also do by caching built artifacts, just storing them and passing them along to subsequent job runs, which is also very useful. Again, built artifacts is another one. You can store entire applications for example, for the deployment step or so on. If you're relying on building Docker images, for example, if you're making an app that deploys to Kubernetes, you can actually utilize Docker layer caching as well. which essentially caches each single kind of instruction in a Docker file. For example, run, copy, all these kind of instructions. They are cached as layers, and you can actually reuse all these layers up to the one that actually contains a change. So that's just like a toggle in Circle CI, and it can really speed up some builds a lot. Anyway, so what we've covered so far was, yeah, using the right size of machine, making sure that things run in parallel, and especially tests are split in the way that runs the fastest. And we are caching all the dependencies so that we're deduplicating a lot of work. These are more technical solutions. But what if we can also look at some non-technical solutions? One example is just reduce the scope. Because, yes, smaller apps, smaller workloads are going to be faster to run. Surprise, surprise. What you could do is essentially run a subset of a build if you don't need the whole thing. For example, if you're in your regular development flow, maybe you don't need to run the whole functional or smoke test suite. Maybe you just need to run the unit tests. And when you're ready to merge this to an upstream main branch or make a release, then you can run the whole scope of tests. So you really speeds things up. Or that's ultimately what helped us a lot, was essentially thinking which tests we actually need and cutting those. Because if you're thinking that what we were building was essentially 100% functional tested application, we were testing a lot of the paths through the app, which took a long time, frankly. And with each application, some of the paths are deemed critical. For example, in a shopping app, path to add something to a bag and checking it out, or adding a credit card, they are pretty critical for an app to work. But changing someone's email address might not be super critical for functionally tested applications. So you really think about what you need, or what you get the most value from having tested, and just as that, and reduce the rest, which will make the whole thing run faster, decrease the risk of flakiness, and so on. And of course, you can't have a DevOps talk without mentioning the teamwork, because we're all working in teams, and the better the team works together, the more effective and the more productive they are. In a CI/CD sense, a team is ideal team is involved in the whole process. So there is no single maintainer of the CI. There is no single person who gets to fix everything. In my case, I was mostly the person who was fixing everything, because I frankly liked fiddling with those things. But you really benefit from having everyone sharing at least a basic level of understanding of what is actually the CI doing, what the processes are, and knowing where to look for changes, and how to suggest improvements. Because yes, your team will tell you that something is wrong, but maybe they'll also look at how they could improve this themselves, which is really good. And the other kind of side benefit of having like a great CI/CD process is, when you're onboarding a new member, you can basically point them to that script and tell them, "Hey, look at how the CI does it." That will tell you how everything is built, and that gives them a really good idea of what moving parts your application has, which is really great, because you don't have to really document all that much. I mean, you still have to document, but you don't have to document all that much. Anyway, And of course, you avoid the boss factor of a one person that knows everything and the rest don't know what's going on. And when the CI breaks, everyone can actually go fix it. Anyway, now it's up to you to think about what is the right build time for your team. Obviously, some of you have mentioned it already, 5, 10 minutes, or not longer than 30 minutes. But really, it is up to you to know that for your team, for your application, what's acceptable to you, what you really want, what you really are looking for. If you want to compare yourself to others, we regularly release these annual state of software delivery reports, which contain a lot of information about folks who are building on our platform, teams from all around the world, and we really collect a lot of data. Like there's 55 million data points from three portions of 2020, and how teams have been building, how their build speeds have moved, how what their throughput looked like, and ultimately that can give you an idea of where you sit, comparing yourself to your other teams, maybe in your technology, maybe in your industry, and so on. So but the thing about speed is it's not really that important. Yes, I know the title is Need for Speed, but I think that CI/CD speed is it's not a race. The ideal time is less to do with you're doing something in 4 minutes versus in 5 minutes, or doing something in 10 minutes versus in 20 minutes. It's about getting that kind of signal which tells you, yes, your app is working, or yes, your app is not good to ship. Getting that signal across, yes, as quickly as possible, but still getting the signal across. A test that runs for a build that runs for 30 seconds will tell you a lot less about the quality of your app than a build that lasts for 10 minutes. So thanks for sharing this link. Someone shared this in the chat. So CI/CD is really not a race, and yes, it's more like an ambulance instead. So it should go very fast, yes, but it also should carry that signal across reliably, because your signal is your most valuable cargo. And yes, if you see the red lights flashing, then you should go and fix that build. Anyway, my name is Markan. This was The Need for Speed, and I hope you learned some tips about optimizing your CI pipelines. If there's any questions, I'm happy to take them now. Is it possible to get this presentation really liked it? Yes, of course. I will. Let me share this presentation. I think I can upload this to the system. Otherwise, I will see if I can just download this thing. PDF. Yes, I will see if I can drop it into chat. If not, I will. I don't think I can drop it into chat. I mean, obviously it's a Google slide, so let me just make a copy. Okay, I'm making a copy, and I will be sharing it momentarily. Share. Yeah, I am sharing the presentation in the public chat. So I hope this is accessible. If someone can click on the link and access it, let me know if you can. It should be, it should be not protected. Is there any other questions? Okay. What do you think about the influence of testing strategy on CI/CD speed? I'm a big fan of testing, and I think that like any testing strategy you have should be as ever encompassing as possible. So test as many things as possible. But yes, the more tests you have, the longer they run, the the slower your CI will execute. Obviously, with things like parallelism, with things like caching, you can bring it down. And obviously, if you kind of run a subset of tests on each build, on each commit, for example, you can still have a substantial test suite that covers really a lot of things, um, and still not kind of hold you back as you're developing. Um, but yeah, like you should still kind of be looking at this testing pyramid of yeah, the bulk of the test, the bulk of the heavy lifting is your kind of unit at your unit level, and then the more abstract up you go, you have fewer tests that cover mostly the critical paths. So I think that's still like holds as it held 10 years ago. And but yeah, the longer the more tests you have, ultimately it's gonna be more it's gonna take longer. But yeah, you can split it up. The other, I hope this answered your question, Dennis. Uh, Another question was, let's say I have a project with 500 plus Git repos in single build pipeline. How can I sync Git sources? Takes around 2 hours. Wow. How can I utilize caching here? Update new projects in cache. Wow, that's a cool problem. I mean, it's a hard problem, but it's also cool. Um, you can usually cache whatever you load. Whether there's kind of histories to if you know that all these kind of git repos haven't changed, which usually you can get from just a log call that tells you what the latest commit is. So maybe you can create like different caches for every single of those repos, and use the hash of the commit as that key that you cache against. So if that cache has if that hash hasn't changed, then you know that your cache is still up to date for that particular Git repo. Whether that changes or not, depending on if you have uh, like uh, like dependencies that rely on this, I don't know. So it seems like you can try different things, but yeah, I would see if you can make like multiple caches with different um, ultimately like names or like keys for each of those repos, and see whether you need to reload them again. But yeah, it's a very, very cool problem. um, Actually, I mean, if you email me, like we can take this offline, and we can maybe I can kind of consult with some of my support colleagues or my colleagues who might have seen this problem before. So my email is zan@circleci.com or @zmarkan on Twitter. So I hope this helps. It's definitely not something we can answer in 1 minute anyway. Um, so yeah, I hope this was this was good. Anyway, thank you all for attending. Thank you for the questions. I hope you stay safe, take care, and enjoy the conference. Bye.